Good morning and good afternoon, scholars. Welcome back to Mr. Sniffen's summer geometry class. Today we're going to be talking about some of the earlier concepts within geometry. We're referring to our slope formula and our midpoint formula. But today, just like we're going to be doing for the next 3 weeks, we're going to be looking at real-world examples and how we can relate this information to tangible real-life occurrences and kind of transpose those onto how we would normally see them rendered in a geometry class. Since we're starting at the beginning of geometry, since we're kind of like working our way up, today we're looking at the basics of the coordinate plane. Coordinate plane is essentially just a map that we can use. We don't necessarily see it in the same way as a typical map that we would look at, say, like on Google Maps and we're trying to go on the subway, or if we're just trying to travel across the country. But whenever we're looking at directions, just like we said yesterday, we consider time as part of our direction process as humans, but really we're looking about two different types of coordinates. We're looking about east and west and north and south, or left and right and up and down. In a coordinate plane, that's essentially our x and our y. Our x measures how far left we're going, how far right we're going on our coordinate plane, positive and negative, and our y dictates kind of that top to bottom portion, that positive y going up, that negative y going down. Let's take a look at Google Maps. With Google Maps here, we're looking at the heart of Manhattan. We're right in Midtown, where we have a ton of numbered streets going left and right in terms of our avenues, and going up and down for our, say, our y values, our numerical streets. So Manhattan's a perfect place to show this off, and let's take a look at a few things. Whenever we want to go from one street to another, we always have the possibility of counting. Like for instance, if we're just south here of Bryant Park on 38th Street and we wanted to travel north up to 46th Street, we can do kind of a quick calculation in our head, or we have the ability to just count out the number of streets. To go from, say, 38th to 46th, we can just go ahead and count up each individual street, or count down from 46 to 38, or we can just do a simple math equation. This math equation that we do is basically like our slope formula, that difference in our coordinate plane. When we're going ahead and using our slope formula, we're talking about an equation where we are looking at the difference between our x values and our y values. So slope formula, you might remember, is that y2 minus y1 over x2 minus x1. But what we're really looking at is how far up we're going, how far down we're going, our difference in y as a mathematical term, difference meaning the amount of numbers in between, and then our x values. So for instance, if we wanted to set up kind of like a pseudo coordinate plane equation and we're going from, say, over here at the corner of 6th Avenue and 38th up to, say, 46th Street, and we want to go over to 10th Avenue, we would take our numbered street of 46 minus 38, those would be our y values. We'd solve, we get a difference of 8, so we're going up 8 streets, and if we want to figure out how far it takes to go from 6th to 10th, we would do 10 minus 6 and we get 4 streets. So we kind of do this normally in our head, but we don't transpose it over to a coordinate plane. That's what I want to impress upon you. We're talking about coordinate plane, we're just talking about a mathematical means of direction. All right, let's look at our notes for today. We're looking at, once again, our slope and our midpoint formula. Whenever we're taking our notes, we want to label our page, essentially the title of the video, because that's going to be our description for today. But let's start right before we get to our actual direct slope formula. Let's take a look at these two things right down here. First off, we want to talk about Euclid. Euclid from yesterday, from our video, the grandfather of all geometry. He used this concept called a postulate, this Greek word called a postulate, that basically means it's a statement that we take to be true because it's already been proven. Like, for instance, nobody really needs to argue Michael Jordan's the best basketball player. It's already been proven. We already know that to be true. Postulates can be silly things like that, but more realistically in the science world, the mathematical world, it's things that we know are facts. They're laws, essentially. We're beyond our theories, we're into concrete laws. If we want to find the average of something, we know we add up all the individual pieces and we divide it by the number of different representations. With a postulate for today, we're looking at our slope formula. We know to find the directions between two things, we do that notion of rise over run. The way that's expressed numerically in terms of rise over run, that's that formula of y2 minus y1, x2 minus x1. That's how we go about finding our slope. That's about how we go about finding our directions on a coordinate plane. We're talking about the difference of y's represents how much up and down or how much north and south on our New York City grid system we go. And our difference of x, meaning the numbers between them, that represent x2 minus x1. So for your notes, what you'd like to have set up here, we have our example, we have our formula next to it. If you need additional directions, additional reminders, you usually want to kind of put them next to each other. It makes it a little bit easier to represent. In my mind also, how I always set up my paper in school when I take notes, my left-hand side is like little additional interesting facts or reminders and things to kind of plug in. Same thing if you're annotating text, you're annotating your actual notes here as well too. Okay, so let's slide down. Since we're going through here quickly, let's take a look at how we would actually represent this numerically. How would we actually go about practicing equation like we're going to do with delta math after. Let's take a look down here. We're going to do two separate equations here. In our first equation, we have 2 points represented in our coordinate plane as x1, y1, x2, y2. We have 2, 8 as our x1, y1, 10, 12 as our x2, y2. We want to go about setting this up as what we would call as like an equation. We're going to take our y2 value of 12, subtract 8 from it. That's going to be over, kind of like looking like a fraction, as 10 minus 2. If we go ahead and do our little math here, 12 minus 8 is 4, 10 minus 2 is 8. When you're working with slopes though, you want to make sure to reduce your fraction if you can, if it's nice and easy, and 4 over 8 is equivalent to 1 over 2. 4 goes into 4 one time, 4 goes into 8 two times, 1 over 2. Let's take a look at our next piece here. On the bottom, our second example, we have 0.34 and point -10, -15. If we're going to go ahead and use this same formula, y2, y1, x2 over x1, our equation is going to look a little bit like this. -15 minus 4 and -10 minus 3, -15 minus 4, or 15 plus 4 gives us 19, -10 minus 3 gives us -13. For this particular fraction, we're basically done. There's no easy common denominator that's not a decimal between them. All right, so this is our slope formula. We're going to use this later in the week when we talk about our line equation, that y equals mx plus b, but we're just getting that first portion of that equation, that m value. Let's go to our next page here. We're going to be talking about the midpoint. Midpoint as a concept is basically the average between 2 points. When we're looking for the average of a set of numbers, we're adding them all together and then dividing by the number of groups that we have. Here along the top, I have a straight number line. This would be a representation of just one numeric value. If we're looking at a number line here, if we were to go from point 10 to point 20, we know that, okay, in our head, kind of the middle of 10 and 20 is 15, but we can also just do 10 plus 20, which is 30, divided by 2, and that lands us right at 15. But if we're doing something on a coordinate plane when we have two directions, we have a north and south and east and west, we're using that midpoint formula, which looks a little bit like this guy right here. Our midpoint formula is going to be x2 plus x1 divided by 2, y2, comma, y2 plus y1 divided by 2. And we're looking at a nice visual representation. We're talking about adding these different lines together, dividing by 2, x2 plus x1 divided by 2. All right, so let's breeze through here, finish up our video for today with our midpoint, and use some examples. Our first example for midpoint are x1, y1, or x2, y2. We're looking at 3, 4, and we're doing 7, 9. If we're going to use that formula of x2 plus x1 over 2, y2 plus y1 over 2, our first equation we're going to do 7 plus 3 over 2, which is 10 over 2, or 5. Our y representation, 9 plus 4, or 13 over 2, which is equal to 6.5. If we want to combine these, we have 5, 6.5 as our midpoint. Our second example here, we're going to do our last example for today. Our x1, y1, our x2, y2. And those are just our different points on our graph. We're going to show you a negative example again, just so you can see it in your mind. For this particular one, we're looking at negative 4 plus 1 over 2, which is negative 3 over 2, or what you would say is negative 1.5. Next example, our y's, we're talking about negative 2 plus 2, or negative 7 divided by 2, which is equal to negative 3.5. We write out our answer. That midpoint of our, say, our segment example would be negative 1, comma, negative 3.5. Since we're just starting our summer classes, want to make sure that we have what our best practices are going to be. Working on notes, we're boxing in our answers, for example, writing our names on our papers, things like that. But when we're talking about kind of what we're going to do after the videos, it's this website called Delta Math. Delta Math allows for you to basically practice various questions in our class and allows me to assign them, see how much you completed them. One of the benefits of Delta Math is that when you actually go ahead and put in your, say, answers for 2 points, if you end up doing, maybe, I'm just picking random numbers here, but you end up punching in an answer, it tells you why you're wrong, essentially, and it gives you examples of how to do it. So Delta Math is pretty good. Occasionally you'll see things that look a little bit wonky, but what's nice is they'll show you a visual aid in terms of how they went and solved for everything. What I need from you, though, is that when you're going ahead and completing these questions, like for instance today you're doing about 8 midpoint questions, 8 slope questions, is I want for you on your paper to basically be solving everything out, and I want you to take a picture and upload it to Google Classroom for me today. That way I can see that one, you're actually doing the work, but two, I can kind of go through and see numerically where you may or may not be making mistakes or little tips and tricks that might help you in terms of keeping your work organized or maybe completing it quicker, things like that, and helping you out with those logic steps, which is what our main focus is right now. So once you finish Delta Math, what you're going to be going ahead and doing is going into Google Classroom, going to the assignment for today, which would say like Delta Math, slope, and midpoint formula. You take a picture of your piece of paper that you wrote everything down, take a nice clear one, upload it, and that's how you get essentially credit for today's assignment. So it's not just completing the questions, it's actually showing the work for it. But that's it. Um, Besides that, for today, um, that's it, basically. That's it. So if you have questions, please feel free to reach out, come to office hours, talk about anything, history stuff, math stuff, kind of the synergy of both, or once again, just midpoint slope, up to you. But until next time, stay safe, wear a mask, don't be silly, wear a mask, and wear a mask. All right, bye.